Is her talking?
No.
Yeah, I'm so sorry about that, guys. I didn't realize the mic was muted. Yeah. So I was saying now that this is what happens whenever you have a series circuit, right? Current remains the same, which means that throughout all of these components, all of these light bulbs in this circuit, it's the same current that is going to be delivered right across them, right? And in addition to that, I said that if my light bulb was supposed to break here, then it means that it will stop the flow of the rest of the current. You can go ahead and draw the schematic diagram in your book. Are we following, by the way?
Yes.
So what did I say about series circuit just now, Kyle?
So you said that in series circuit, if one is one component is and whole thing is not going to work. So, and so
Alright, mute them. Someone that person, mute them mind quickly. Go knock on the door. Then if it's not knock on the door. Alright, so that's correct, Kyle. Now in a parallel circuit now, things are a little bit different, right? Whereas now the components are connected in branches or in some cases them as loops. Alright. So I'm not sure if you see my screen clearly, but you can go ahead. And it says that if one section of the parallel circuit is disconnected, the current continues to flow through the remaining sections. All right. Whereas when you look at the series circuit, you realize that if something got disconnected, then no current will flow. All right. See if I can build a parallel circuit very quickly to show you. All right. Are we seeing the circuit on my screen? No, I'm gonna close this switch.
Yes, sir.
When I close that switch, the light bulb up top here continue to work, right? Whereas now when this one in the middle is disconnected, then no current is flowing through that section, right? So the point that I just made a while ago to say that if something gets disconnected in a parallel circuit, the current is going to flow through the other components, right? And not flow through the one that's disconnected. Whereas now if I was supposed to open this and close this, I would expect that now this one is going to work. Guys, this is the kind of circuit that we use in our homes, right? If we didn't use this type of circuit, then a lot of things would happen. When you turn on your microwave, maybe a light will come on. When you open the door, something crazy would have happened, whatsoever it is. If your door is connected to your electrical whatsoever, right? So this is one advantage of the circuit because it gives you more control over each component, right? Hence the reason why we use this kind of circuit. So in addition to this now, guys, when it comes down to the current flow, we can say that the current is divided in this case. Whereas in the series circuit, it said that the current remains the same, right? No. Haley, mute your mic.
Hold on.
In a parallel circuit, we can see now that the current is divided in this section, right? So that's important point to note. So when you look at this second point here on my screen, and it says that the current flowing through the parallel circuit is not the same throughout the circuit, meaning then that, you know, whatsoever current is flowing here is not going to be the same current that is going to flow here. So you're going to have a different current here. We call this I1, and we're going to call this one I2. Right? Now guys, this thing here, we know that this is a light bulb. You know, in its natural sense, this is a light bulb. However, whenever you're doing circuits in physics, this is a component that you would have to use to represent a light bulb. In addition to that, this is the regular symbol for a battery or a cell. Whereas now, in the schematic world, this is the symbol that we use. All right? Now, are we understanding, by the way?
Not really.
What is it? Talk to me, guys. What is it that you guys don't understand? Or what do you understand so far?
Alright, so like so the current is going to like you have to use the one that's connected to is going to flow through to the one that's not going to get any
Hold on, Kyle. We're not here, so clearly move the phone a little bit away from your mouth. Let me see if that makes a difference.
Alright, so we were saying that the current was flowing, that is flowing to the one that's connected is going to like light bulb connected to is going to turn on to like more easy to the house, and the one that's disconnected. So you have to get the energy, so you have to kind of disconnect the one and connect it.
So what can we say that is happening to the current in a parallel circuit? Is it the same?
No, sir.
Okay, it's not the same. So we say that it is divided, right? So that's the term that we're going to use, that the current is divided in parallel circuits. Fair enough? Healy, talk to me.
So I'm just at a loss.
Say that again?
I'm just at a loss.
Hey Kyle, you don't have to talk now. Are you meant to talk, man? Healy, what are we saying?
I'm at a loss. I wasn't sure what.
But Healy, you know it's class time now. You can't absent, man. Are you there, yard? Huh? Alright, we want to talk about, we talk to you differently, alright? We want to talk about the different kind of circuit symbols, right? So typically when you draw your circuit, you're not going to use a regular battery that what you call this? A AAA battery. You're not going to draw a AAA battery instead. You're going to use the symbols that are recommended, right? So whenever you have a single battery or a cell, this is what you would draw, right? Now, I'm going to redraw it again because it's kind of a little bit blurry. Now, the longer stick here is the positive terminal, whereas the shorter one is going to be the negative terminal, all right? So with batteries, our cells, they have different terminals, right? And we are in physics, we use the longer side to represent the positive and the shorter side to represent the negative. Whereas now when you have a battery is a combination of more than one cells, right? So clearly we can see that this battery is a 2-cell battery because we see one cell here. Is it a two cell? Yeah, let me check. Or maybe it's a 3-cell. So it is 3-cell actually. So that's one cell. Then now we see another cell right here, which is 2, and then it's 3, right? So this is a 3-cell battery. So you can look at that to know whether it is a 3-cell battery or not.
So the one above it is a 2-cell?
No, it's a 1 cell. It's a cell, not a battery, but it's just a cell. We refer to it as a cell. All right, and that's because it just only have one positive and negative terminal. Now, the next point we're going to look at is a light bulb. So there are 2 symbols, right? So if you do work up on these, then you know that it's talking about a light bulb, right? So there's like a curved part here in this one, right? You know, once you make note of this curved part, then you should know that that's a light bulb. Then if you have the one with an X, it's the same thing as a light bulb, all right? Now, we have used switch before in our previous circuit, right? Right, as you can see on my screen here, this is the thing for an open switch. So if you're supposed to draw a circuit diagram and it says insert a switch, you would have to go ahead and insert your switch like this. This would be the open switch. Whereas now, if the wires are touching each other, like this, now we're going to call it a closed switch. Alright. Alright, now connective wires. So we know that we have to use wires in circuits, right? And to represent your wire, you just basically draw lines, you know, right? That will represent your wires. So that's pretty simple. Now there are different components as well. There are other components that we'll go into as you go along. You learn more. Let me see if I can scroll on this thing here. Now there are 2 specific devices here that, you know, I don't know if you have come across them before, but these 2 components are very important. One is an ammeter, the other one is a voltmeter, right? If we know the units for current, we'll realize that this is almost like a root word for amps or amperes or whatsoever it is, right? But typically from that understanding, we can say that this must be a device that measures current, right? And it is, right? So an ammeter measures the flow of electric current passing through, you know, the circuit, right? And with an ammeter, the important point to note is that ammeters are always connected in series with the components. So all of these things that we're talking about so far in the world of electronics, we refer to them as components, all right? So don't be confused with that term that I just used, components. It is talking about all those individual things that we can connect up in a circuit. Did we take note of this point a while ago?
Yes, sir.
Good. I hope I have everybody's attention. Is Nardia in this group, by the way?
No, sir.
Lenward, I haven't heard from you for morning, man. What's up?
Nothing much, sir.
Understanding, man?
Yes, sir. So far.
Alright, Dana Lee, win. Talk to me.
Sir, I'm taking the notes and listening.
Then do you understand?
Yes, sir.
Alright. Matthew Plummer.
You hear me?
Yes, sir.
You understand, man?
I just reached.
Brother, wow, how did you just reach? Eh?
Just
Sir,
wake up.
oversleep.
You know, easy, brother. School time, man. You can't. Hey, Matthew, are you
So,
come from
yeah.
Prospect?
Sorry, sir.
A Prospect you come from?
No, sir. But what that have to do with it?
I'm just ask a question.
Oh,
But you're late, brother, so I'm sorry for you, you know. You understand?
yeah, man, I get the notes later.
Alright. Now, kind of running out of time, but now a voltmeter now, guys. As the word suggests, volt. So that would come from the root word voltage. So from that we can agree that it has to do something with voltage. And that is basically a device that measures voltage, right? You know? So whenever you have a circuit and you want to know what amount of voltage is going across your components, you would have to use a voltmeter, right? And we'll see why we need to measure the voltage in circuits that is in our syllabus requires of it, right? But eventually you'll find out and you'll use it if you continue to do physics at the fourth form level, right? So that's a voltmeter. Now with a voltmeter, guys, important point to note: voltmeters are connected in parallel to the components. Alright, now I'm going to show you what I mean by that. So you can just record that point very quickly. See if I can scroll up to the image that I have over here. Alright, let me just erase this. So this is my parallel circuit. And by what I mean now, if I'm supposed to measure the voltage across my battery, not my battery, my light bulb rather, right? I would have to go ahead and insert my connective wires here at this end. And then now I'll draw my symbol for the voltmeter, which is a circle with a V inside of it. Then now I'll connect my wires to this end. When you look at this now, this is in parallel with this. So that's why we say that it has to be connected in parallel. And it makes sense. You want to record the voltage at this point and at this point that is flowing through, or that is flowing across your light bulb. Right? So in order for us to get that value, we have to connect it in parallel. In addition to that, there are other reasons why we do connect it in parallel, but we won't go through that right now. Now, when I was talking about the ammeter, if I want to measure the current that is flowing through this part of my circuit, I would have to now insert my ammeter here. So I'll put that circle and put the A right here, which is my ammeter component, that is the symbol for it. And then this thing here would measure the current flowing through this thing, right? So that's what we mean by having your voltmeter in parallel, and then having your ammeter in series. Are we getting that? Hello?
Yes, sir.
I hope so. You'll be tested greatly on this. Alright. Now, another component, another very common component is our resistors. And as the word suggests, resist, it means now that it's going to limit the flow of charge, or it's going to limit the current that is flowing through, that part of your circuit. Now, typically, most components have a resistant aspect to it, which means that it's going to limit the flow of charge to some degree. You have some components that does it to a greater dimension, and you have some that does not do it to that greater dimension, right? Now, on another note, right, we have a set component that we use to insert in our circuits to limit the flow of charge. So typically, maybe you have a component that you don't want a lot of current going to. So then you now have to think about your calculations, because that component needs certain amount of current to operate, right? And if you insert a resistor that is going to resist that amount of current that the next component needs, it's going to affect the whole aspect of the circuit. You understand? So you have to work with the calculation to say, all right, what value resistor do I need in order to not have excess current flowing, but the right amount of current flowing so that my light bulb can work in its normal sense. You understand? Now, there are different types of resistors. We have a fixed resistor, which is basically like this one. Now, there's another symbol for resistors. You would see it like this. So it's a line with some squiggly looking thing, right? And you have the one with the box. Now, we have also what we call a variable resistor, which means that whenever you have a fixed resistor, by the way, it means that if it is 200 ohms, so the units for resistance is ohms, by the way, and we will learn more about that at some point. And that is how it looks. This thing here. That's how ohms symbol looks.
So how it's spelled?
So that's OHMS. So it is OHMS. Ohms. Alright. In addition to that, I was also saying that there are variable resistors, right? And what it means with a variable, you're able to change the resistivity of that resistance, meaning that you can get a high resistance, you can get a low, you can get a medium range resistance, right? So with that, this would be the symbol, having the same box looking resistor, and then you would have an arrow going through the resistor. So that's a symbol for the variable one. And it will be the same thing for the one that I have the squiggly looking line. Just use your arrow and insert it right across there, right? So that would represent the variable resistor. And as I said, it means that you can adjust the resistance, right? So if there are any questions, go ahead and answer questions. If there are any misconceptions, go ahead and state your concerns. Talk to me, fellows. Talk to me. Silence causes violence. You guys are a nice bunch, you know. Remember that, you know. I'm gonna unmute all of them. Brown, talk to me. I haven't heard from you. Who's Carlene, Brown?
Sir,
Who's Carlene, Brown?
Javon Thompson.
So what your name, Carlene Brown, my youth?
My mother account.
You know, your mother their class now. Are you their class? Are you understanding, sir?
Yes, sir.
Okay. Take your word for it, you know. Kyle, what you say about you?
Okay, none of them, sir.
Alright. Healy, talk to me. Where's Haley?
Yes, sir.
You understand what's going on now?
Yes, sir, but I'll get a better understanding like when I get my notes.
Alright. Alright, Shamari.
Sir, I can like go over, like scroll up, sir, scroll up.
One second, man. Where that? What you want me to explain, man?
Right there, sir, go down.
Why if you go wrong things still?
Sir, that diagram with the bugger writing with parallel and go over the one, right?
So I was talking about your voltmeters, right? So we said that in order for your voltmeter to work at its best, it has to be connected in parallel with the component that you're measuring the voltage of. So I don't know the voltage that is flowing through this light bulb, right? I need to know the voltage. The required device that is used to do that is what we call a voltmeter. Turn off that. Who make that sound? So you need a voltmeter. Now, your voltmeter has to be connected in parallel, right? In order to measure that voltage across the component. In addition to that, now, when we talk about ammeters, your ammeter must be connected in series with the component. So right here, we had to connect the ammeter here, right? And one of the reasons now, guys, remember when we're talking about series circuit, we said that the current is going to remain the same. So right here, if I measure the current at this point, it's going to be the same current that is going through this component. You understand? So that's what it is in a nutshell. I don't know if I answered your question, but let me know.
Yes, sir.
So for Miss Haley now, I hope I didn't mispronounce your name.